More than 1 billion miles away in the outer solar system, Uranus, the 7th planet from the Sun, can be found. Along with its neighbour Neptune, Uranus is considered an ice giant, a class of gas planets that is distinct from the much larger Jupiter and Saturn. It is 4 times wider than Earth, has 27 known orbiting moons, and it rotates at a near 90-degree angle, making Uranus appear to spin on its side as if it is orbiting the Sun like a rolling ball. It was named after the Greek god of the sky, and although this usually puts it at the centre of many space jokes, Uranus is by far one of the most interesting planets in the solar system. Most of what is known about this strange world came from the Voyager 2 spacecraft as it made its historic flyby back in 1986. Voyager 2 gathered a lot of critical data on Uranus, its moons, and its rings in just 6 hours as it passed within 50,600 miles of the planet's cloud tops. The rest of what is known about this ice giant comes from observations via Hubble and several other powerful ground-based telescopes. All of this valuable information has allowed scientists to study many aspects of Uranus, including its internal structure and composition, giving us an incredible insight into what lurks deep below the distant planet's mysterious clouds. Just like the other 3 gas giants that we have already explored, this mission would be impossible for any human being, so let's assume that you have once again been equipped with a fully charged, special science fiction spacesuit that will take you all the way to the core of the planet and protect you from the devastating environment that Uranus has to offer. As you fall towards Uranus, you would get a magnificent view of the ice giant's external features, such as its faint ring system that is mainly made up from tiny, relatively dark particles of ice and dust. You would see the planet's turquoise hue, but unlike the bland photographs that Voyager 2 captured all those years ago, you would get a first-hand view of Uranus's swirling atmospheric bands as you gradually approach this strange, hazy planet. You would eventually enter Uranus's upper atmosphere, where you would fall through clouds of frozen methane that is mixed with hydrogen and helium. At this altitude, the pressure would be approximately 0.5 atmospheres, which is half the atmospheric pressure at sea level on Earth. The incredible distance of Uranus means it receives very little light from the Sun, making its atmosphere the coldest in the solar system, below -220 degrees Celsius. Because Uranus has a low density, its gravity is slightly weaker than our own planets, which means you would be initially descending at a similar speed to if you were free falling towards Earth. It wouldn't take long before you passed through this first layer and into the murky region of hydrogen sulfide ice clouds. The further you descend, the darker it is becoming, and the less you are able to observe, as the sun's light cannot penetrate to this depth. However, you would hear and feel the violent winds that are whipping past you at speeds of up to 560 miles per hour. Luckily, your special suit once again keeps you steady and allows you to continue into this hellish abyss. At this stage, you would have plunged through approximately 80 miles of thick, dense, dark clouds. The light of the sun would seem like a distant memory as you find yourself in a pitch-black, lonely environment. However, the atmospheric pressure at this depth would have increased to approximately 10 atmospheres, and the temperature would now be a comfortable 10 degrees Celsius. But it wouldn't stay like this for long, because you have just fallen into the chaotic region of towering white water ice clouds, where static electricity generates huge arcs of lightning that are flashing all around you. As you approach the bottom of this cloud stage, the pressure would rapidly increase to above 60 atmospheres, and the temperature would be around 50 degrees Celsius. Over an hour into your journey, and you are now 150 miles into Uranus, and starting to realize that your surroundings are becoming more and more intense. By using a lot of your high-tech science fiction spacesuit's power supply, you can now see the mysterious environment that you are continually transitioning into. A strange, almost bottomless icy sea that is possibly more than 2,000 times deeper than the Pacific Ocean. This region is called the mantle and could make up more than 60% of Uranus. But it is not the type of ice that you normally see. Instead, it is a hot, dense fluid of icy water, methane, and ammonia. As you sink through this magnificent mantle, you would notice that it is becoming thicker, eventually slowing your descent as your density equals out with the environment around you. But as always, your super science fiction spacesuit allows you to continue so that you can see what lies beneath. As you slowly sink deeper and deeper into Uranus, the temperatures would continue to rapidly increase due to the colossal pressures that are now in the thousands of atmospheres. These immense pressures might also cause carbon atoms to crystallize and form millions upon millions of diamonds that are glistening all around you. After weeks of sinking, you would have now traveled thousands of miles into Uranus and possibly found the planet's center, a small core that is made of highly compressed rock, iron, and exotic ices. At this stage, you would have completed your mission and your adventure would have come to an end. You would be stuck within this hellish ocean for as long as your special suit can prevent you from becoming a part of Uranus forever, as it attempts to withstand the scorching temperatures of around 5,000 degrees Celsius and pressures of above 7 million atmospheres.